Hello everyone, welcome to Supply and Demand lesson number 6. This is the last one. This is where we introduce algebra into supply and demand. Okay, so let me move my image. Here we go. So this is a basic supply and demand graph that you've probably seen 100 times by now. And all we want to do is take that demand curve, and instead of writing demand curve, let's write an equation that describes the relationship between prices and quantities demanded. So I've just made up this simple little equation: quantity demanded equals 50 minus 2p. Let's do the same thing for the supply curve. So we erase the term supply curve and instead insert an equation that describes the relationship between the quantity supplied and the price. Now, with these two equations, it's possible to find the equilibrium price and equilibrium quantity. You probably should stop this video at the moment, go ahead and work it out, and check your answers against mine. But if you set the quantity supplied equal to the quantity demanded, you'll discover that the equilibrium price is 13. Once you have the equilibrium price of 13, you can take that 13 and you can stick it into the supply equation or into the demand equation. In fact, I recommend you do it both ways to check your work. But stick it in either place and you'll get the equilibrium quantity, which in this case is 24. So take a minute, work those out, make sure you can do it, and then restart this video, because what I have for you is a hold on a minute. Yeah, what I have for you is an old exam question. Alright, here's an old exam question, and I thought we might just work through this. So you're given a demand equation of 1450 minus 2p, and you're given a supply equation of 4p minus 50, and then you're asked a series of questions. The first two are really easy. What is the equilibrium price and the equilibrium quantity? The others are a little more subtle. For example, it says, how much would consumers want if the government gave this product away for free? Well, in this case, if the government gave the product away for free, that would be this price up here. So if we set the price equal to 0, how much would people want? That's what that question's about. And the next one is, how high must the price rise before the first producer decides to enter the market? So that relates to the supply equation. And what you would do is you would set the quantity supplied equal to 0, and figure out what price would be necessary to get the first producer to come into the market. Then question number 5 is about a price ceiling, and question 6 is the same question over again, except now it's a price floor. Alright, so let's try these. Now I've set them up on a whiteboard. Let me see if I can get that for you. I think this is it. Yeah, here we are. Alright, let's work them out. So, you're given a demand equation and a supply equation. To find the equilibrium price, you just set the quantity demanded equal to the quantity supplied. That's your first step. And then by substitution, the quantity demanded is 1450 minus 2p, and the quantity supplied is 4p minus 50. And now all you have to do is solve this thing. I'm going to add 50 to both sides first, and that gives me 1500 minus 2p equals 4p. Now in this step I'm just going to add 2p to both sides, and I get 1500 equals 6p. And then if I divide both sides by 6, I get p is 250. So the equilibrium price is 250, so I'm going to erase this equilibrium price over here, and I'm going to write instead what it is, which is 250. Okay. Then the next question is, what's the equilibrium quantity? The equilibrium quantity. So to find the equilibrium quantity, the definition is the equilibrium quantity is the quantity demanded or the quantity supplied at the equilibrium price. Those of you who aren't real good at algebra, you should remember that. It's just the quantity demanded or the quantity supplied. It doesn't matter which one. I'm going to use the quantity supplied because in this example it just looks simpler. So I'm going to write QS equals 4P minus 50. All I've done is copied the quantity supplied equation, but I could have used the quantity demand equation, and you should probably do it both ways to make sure you understand what I'm talking about. So the rule is the quantity supplied at the equilibrium price, and the equilibrium price was 250. So I'm just substituting in now 250, and 4 times 250 is 1,000, minus 50 is 950. So the equilibrium quantity, I'm going to erase that equilibrium quantity and write instead what it is, which was 950. Alright, that was the first two questions. Then it asked, how much would consumers want if the government gave this product away for free? Alright, so how much would consumers want is a question about the demand curve. How much would consumers want if the government gave this product away for free? So if we set the price equal to 0, I think I did that. Did that work? I'm not sure. Is it gone? Yeah, I think it is. You set that equal to 0. Then I hope you can see that the quantity demanded would just be 1,450 minus 0. So the answer is 1,450. So the answer to number 3 is 1,450. Now visually, in hindsight, maybe it would have been better to do that visually. Let me see if I can kind of undo my work. Let's see, this was 2P. Alright, so visually what's happening is if the price is 0, the demand curve of course just extends down like that, and this right here is how much folks want when the price is 0, and that number was 1,450. Remember, this was the price on the vertical axis, so a price of 0 would be down here at 0, 0. Alright, so the next one is the only one I think is at least a little bit hard, and that is, how high must the price rise before the first producer decides to enter the market? So since this question is about producers, it relates to the supply curve, and what we want to know is, how high does the price have to get before the quantity supplied sort of breaks away from 0 and becomes some number? I hope you can see that that occurs over here on the graph right there. Now the way to find that is you just set the quantity supplied equal to 0 and you figure out what the price would be. So adding 50 to both sides and dividing through by 4, I get P is, I think that's 12.5. So this number right here is 12.5. Now for those of you who are pretty good at algebra, you might be a little bit puzzled by this because these equations look like they're in the form y equals mx plus b. Those of you who, remember your algebra, y equals mx plus b, don't you want to think that this is the slope? Doesn't that kind of look like it? And then this must be the y-intercept over here. But it turns out that these equations are upside down. They're not in the form y equals mx plus b. Just as a little side note for those of you who are thinking about this, in the old days when you had x and y, you might have some line like this. Let's just make up something. Let's say this number is 50 and the slope of this thing is 2. Then you would have an equation that went like this: y is equal to 2x plus 50. Y is equal to 2x plus 50. I don't think that 50 showed up. Yeah. But in economics, P is on the left side. I beg your pardon. P is on the right side, not on the left side, and Q is on the left side. So it's kind of backwards. So you can't look at these equations. I've kind of made a mess now, but you can't look at these two equations and interpret them with the form y equals mx plus b, because they're written upside down. This will come up again when we get to elasticity, but for now that's enough. Alright, so the next question is, well, suppose the government set a price ceiling at 400. A price ceiling at 400. Well, 400 would be way up here somewhere. Price ceiling at 400. Okay, now recall that a price ceiling is a rule that says the price can be below the ceiling, but it may not go above the ceiling. In this case, the natural order in the market is driving the price down to 250, and since we have a price ceiling at 400, well, nothing happens. The price would like to be below the ceiling. It would like to be at 250, so this one is non-binding. Nothing happens. A real-world example of this would be like if President Obama came on TV and said, by executive order, the price of gasoline, we're going to set a price ceiling at $10 a gallon. Well, if it's a price ceiling, price can be below it, and of course it wants to be below that, so it would be non-binding. Alright, so then nothing happens in that case. And then question number 6 says, well, suppose instead the government set a price floor at 400. Now, if this is a floor, remember the rule is it can't go below the floor. It could go above it, but not below it. So we have market conditions trying to drive us down here to 250. We got a rule that says it can't go below the floor. So in this case, it would be binding. That is, the price would be stuck at 400, and this would be the quantity demanded, and this thing over here would be the quantity supplied. And now, since we have this in equations, we can actually figure out what those things are. The quantity demanded we would just get from the demand equation, so it would just be quantity demanded is equal to 1450 minus 2 times this binding price floor. And when you work that out, I think you will get that that number is 650. So I'm going to erase this and put 650 there. Similarly, the quantity supplied would be 4p, and p is 400, minus 50, and that would work out to be 1550. Hope my math is right. 1550. So I'm going to erase this quantity supplied and put the 1550 there. So then the question was, would it be binding or non-binding? And it would be binding. It would be binding, and it would cause a shortage or surplus. Okay, so here's how you figure that. This 950 is irrelevant now because we're not at equilibrium. I'm going to erase that. So we have a quantity supplied at 1550. This is how much is being brought to market. We have a quantity demanded over here at 650. So this right here is a surplus, and if I did my math right, the surplus would be 900 units. 900 units. Alright, so that's a sample from an old exam. I hope you found that helpful. And let's see, I think that's all we have. Yeah, so here I am again, and that's the end of lesson 6. In fact, that's the end of all the supply and demand lessons, and I hope they work out for you. In my mind, the most important thing is keeping track of the difference between a demand curve and quantity demanded, supply curve and quantity supplied. We covered that in lesson 1. I'm going to generate a bunch of lessons about elasticity, and hopefully you'll find them helpful also. Okay, good luck.